Thanks for joining us. It is 6:47. It's Wise Guy Wednesday, and today our favorite mad scientist is joining us live from his lab.
And this morning, Matt Sullen is answering a very important question. If you scream in space, does anyone hear you?
Good morning, Matt.
Good morning, Gay. Good morning, Matt. So we're gonna see if the school bell rings in space, can you hear it? So that's the question we're going to answer here in a moment. But first, let's remind ourselves what we did last week. We had masses and springs, and we saw that everything likes to vibrate at a certain frequency. Remember that? And it turns out if you have things next to each other that all vibrate with the same frequency, but one is just a little behind the other, then you get this interesting motion like you have right here. Each one of these little rods is moving up and down in exactly the same way that that mass on a spring was moving up and down, but the one next to it is moving up and down just a little after, and so what you get is this wave that kind of moves across. And if you've ever watched TV or been to a football game, you know that if you have one of these stadium waves, you see people, they stand up and they sit down, and that wave kind of propagates across the whole stadium. And that's what all waves tend to do. The waves move, but each individual piece of the wave just moves a little tiny bit. So if you're sitting in your seat in the stadium, you may just get up and get down again. You haven't gone very far, but the wave goes all the way around the stadium. But you didn't have to get up and move around the stadium for that wave to go. So I can illustrate this also with this little slinky here. I can jiggle it a little bit, and we get a wave moving that way towards you, even though each one of these little loops just move back and forth a tiny amount. Now, sound is very interesting. Sound is what we call a longitudinal wave, and you can show that by shoving the slinky a little bit, and you see that you get a squished together piece of the slinky that moves along, but each loop still doesn't move very far, and that's how sound moves. The air, when I speak, gets compressed a little bit, and those compression waves move towards your ear. Okay, so what I have over here is a school bell, and I'm going to turn it on, and you can hear it ringing. Can you hear that?
Yes, yes,
okay.
We can hear that.
So now, waves need a medium to travel through. Sound travels through air, so I'm going to pump the air out of this container, and then we're going to be able to see if we can hear the bell any longer, and you're going to see that we actually can't hear the bell after I've sucked all the air out of this thing. So it's just going to take a minute for this pump to do that. And so you can see right now, if you look inside this bell jar, there's a school bell hanging in there, and it's hanging from some springs, so it's not touching the outside of this jar at all. The only way that the sound gets from the inside to the outside is through the air that used to be inside this thing. And so it sounds to me like the pump is happy. I will turn off this little valve here, turn off the pump. And so right now, you can't hear anything, can you?
No.
Okay, the bell is going, and if you were to look at the little clanger, it's hitting the side of this bell. And there used to be, I think it was from the movie Aliens, the catchphrase was, "In space, no one can hear you scream."
That's
Remember
right.
that one? Okay, this is why, because in space there's no air, and so even if you scream, there's no way for the sound to get from you to whoever is listening to you screaming as the alien eats you, or whatever it is. So now when I let the air back in this thing, you hear it starting to ring again.
Oh, there it is.
And so it was going the whole time, but now you can hear it again because now we put the air back inside this container. So that
answers my question. In space, no one can hear you scream.
That's right. And in the next segment, what we're going to do, now that we've introduced sound, is we're going to use sound to break a glass. And that's a pretty cool demo because something kind of blows up, and I like that.
Yeah, and that's why we're at your lab today instead of our studio. Okay.
So Matt, real quick, is that the same thing as the tree falling in the forest? If you're not there, do you actually hear it fall?
I think that's sort of the philosophical version.
Philosophical angle of it. Gotcha.
We'll work on that in a different segment. Thanks, Mads. We'll check back with you later.
Still ahead on the morning show.